Today we'll talk about graphs of sine and cosine functions. So the first thing to recognize about these graphs of sine and cosine functions is that they follow a curve or a wave. So what I've got here is sine of x, and we'll see that it kind of dips down and goes back up, and then it goes back down and goes back up, and it's following this same wave indefinitely over and over. Here we've got the cosine wave, which is very similar. It just kind of starts in a different spot. If we look at 0, x equals 0, we see that the sine wave starts at 0, 0, then it goes up and then down, up, okay? But it's kind of halfway between the bottom and the top, the bottommost point and the topmost point here. Whereas the cosine wave, if we start at x equals 0, it's already at the top, and then it comes all the way down to the bottom and then goes back up to the top again. So they're kind of the same, just kind of shifted over to the left or right a little bit. Here are the standard forms for both of these. Y equals a times sine of bx minus c plus d. That's for the sine. And for cosine, we've got y equals a times cosine of bx minus c plus d. So in this, a, the number at the front of either the sine or the cosine, this is the coefficient here, this acts as our scaling factor. This creates a vertical stretch or vertical shrink similar to other functions in the graph. And the absolute value of a, okay, when that's greater than 1, the sine curve is stretched, and when the absolute value of a is less than 1, it shrinks. So if a is negative, the sine and cosine graphs will be reflected vertically as well. We also call this the amplitude, specifically with these sine and cosine curves. The amplitude tells us how far up and down this graph is going to go. So the amplitude of both just sine of x and cosine of x is 1, because we see here the highest it'll go up is 1, okay, y equals 1 up here, and the lowest it goes is y equals negative 1. The amplitude is 1. If the amplitude were, let's say, 2, then it would go all the way up to 2 and then all the way down to negative 2, similar with the cosine graph. Okay, what else is important? The period of the function. So one period or one cycle of the function tells us how long it takes for that graph to get back to a point where it's going to repeat itself. So what I mean by that is looking back at the graphs here, if we look at this midpoint right here at x equals 0, it goes up, goes back down, goes down to its lowest point, and then comes back up before it starts going back up again right here at that midpoint. It takes 2 pi for one period, okay, for one cycle of this function. Same thing down here at its highest point. This one might be a little bit easier to see since it's starting at its highest point. It's going to go down to its lowest point and then back up to its highest point. How long does that take? A period of 2 pi. And if we change some parameters or change some things about the graph, then that might change the period where it'll go all the way down and then all the way back up in a matter of 1 pi. That'd be a 1 pi period. Or if we stretch this out horizontally, it might be 2 pi or 3 pi or even 4 pi. Okay. So how do we do that? Well, okay, so it says let b be a positive real number. The period of y equals a times sine of bx and y equals a times cosine of bx is given by a period of 2 pi over b. So as b changes here, that's going to change the period of this. Okay, so when 0 is less than b, less than 1, the period is greater than 2 pi, represents a horizontal stretch. When it's greater than 1 here, the period of y equals a times sine of bx is less than 2 pi and represents a horizontal shrink. And when b is negative, this is going to be reflected horizontally. So I've got all of this information. In this box right here. For c and d, this is similar to other graphs where it's just going to translate the function left and right or up and down, respectively. Most importantly, the thing I want you to get out of this is that the amplitude is that coefficient on a the absolute value of a. That tells us how far up and how far down the graph's going to be. And rather than worrying about translations right now, let's talk about just the period. I want you to be able to figure out how long it takes for us to get back to kind of the starting point, if we will, where the graph is going to start repeating itself. The left and right endpoints of one cycle, okay, one cycle or one period interval, can be determined by solving the equations bx minus c equals 0 and bx minus c equals 2 pi. So I've got 3 examples for us to do today. Okay, the first one, analyze the graph of y equals 1/2 sine of x minus pi over 3. I want you to tell me a couple things. 1, what is the amplitude? Okay, what's the highest it's going to get? What's the lowest this is going to get? And then 2, what's the period? In that, how long will it take to get back to our starting point? So let's start with the amplitude. Amplitude, just look at this number right here. It's 1/2. The absolute value of 1/2 is still 1/2. So the amplitude is the absolute value of 1/2, which is 1/2. Okay, now the period, for that, that's going to be 2 pi over 1, okay, because it's looking at this number here. So it's 2 pi over b. This is 2 pi over, well, b is 1 here, or just 2 pi. And then I want you to be able to tell me how far will it take to get back to the starting point. What's one cycle? What are the endpoints of this one cycle? All right, to do that, I'm going to take x minus pi over 3. I'm going to set this equal to 0. And I'm also going to do x minus pi over 3. And I'm going to set that equal to 2 pi. I'm going to solve for both. So for this one, I'm going to add pi over 3 to both sides. And we'll get one of these endpoints as x equals pi over 3. These are endpoints of one cycle. That's going to be pi over 3. And let's find the other one. Here, let's rewrite this. This is the same as saying x minus pi over 3 is equal to 2 pi in terms of thirds. Well, let's just multiply 2 times 3. That's 6. This is the same as saying 6 pi over 3. Now, since I've got a common denominator, I can just add pi over 3 to both sides. Okay, so I'll get x equals 7 pi over 3. Okay, the amplitude is 1/2. The highest it will ever get is y equals 1/2. The lowest this will ever get is y equals negative 1/2. This has a period of 2 pi, and the endpoints of one cycle, if you will go from pi over 3 to 7 pi over 3. So I've actually got this graphed over here. So y equals 1/2 sine of x minus pi over 3. We see the highest this gets is 0.5, so that's 1/2. The lowest this will ever get is negative 0.5. And I've got pi over 3 right here, and it'll go up, down, and then restart again, 7 pi over 3. Okay, let's look at the next one. Analyze the graph of y equals 3 times the sine of 2x plus pi over 4. Okay, so the first thing, again, amplitude, that's the easiest one. The amplitude going to be the absolute value of this number right here, 3. Okay, well, that's just 3. Okay, what about the period? This is going to be 2 pi over this number right here. My b is 2. Well, 2's will divide out. So my period is pi. And my end points, to get that, I'm going to say what's inside here, 2x plus pi over 4. Set this equal to 0. And 2x plus pi over 4, set that equal to 2 pi. And solve. So let's first begin by subtracting pi over 4 from both sides. Okay, so I've got 2x is equal to negative pi over 4. And then divide both sides by 2. X is equal to, multiply the denominator of this 4 by this 2, which we're dividing by. This is negative pi over 8. So I've got negative pi over 8, and let's find the other one. This is the same as saying, instead of 2 pi, I know I'm going to be working with, let's do a 4 here. So this is the same as 8 pi over 2, or 8 pi over 4. Since 8 divided by 4 is 2. Now I can go ahead and subtract pi over 4. Okay, 2x is equal to negative, so 8 minus this 1 here, so 7 pi over 4. And then dividing both sides by 2, x is equal to, same thing as last time, multiply this denominator 4 by what I'm dividing by, this 2, will be 7 pi over 8. So this function, this graph, is going to have an amplitude of 3. The highest it will get is y equals 3. The lowest it will get is y equals negative 3. It has a period of pi. And for one cycle, this will be from negative pi over 8 to 7 pi over 8. Let's take a look at that graph. So here we are. And we see much taller and much taller graph. It goes up to 3 and then down to negative 3. So it's got a bigger amplitude. And we can see that this is a little bit tighter horizontally. Instead of stretching this out, this is actually coming in more. And negative pi over 8, my halfway point, I'm going to go up, I'm going to go down, get back to that halfway point going up at 7 pi over 8. So this is the second example here. Let's take a look at the third. Okay, last one. Analyze the graph of y equals negative 1/3 cosine x minus pi over 2. So again, I want to find the amplitude, the period, and endpoints of one cycle. Well, the amplitude, let's start there, is the absolute value of negative 1/3. Well, absolute value, that's just going to make this positive. So this is positive 1/3. The period, this is going to be 2 pi over, so we're going to divide by b. Here b is 1. So this will be 2 pi. So far, the amplitude being 1/3 tells me the highest this will get is y equals 1/3. The lowest this graph will get is negative 1/3. And it'll take a full 2 pi to get back to my starting point, where the graph will the wave will just restart. So let's find some endpoints for one of these cycles. So we'll say x minus pi over 2. Set this equal to 0. And x minus pi over 2. Set this equal to 2 pi. We'll add pi over 2 to both sides. All right, so x is equal to pi over 2. And what about over here? I'm working with a denominator of 2, so this 2 pi is the same as saying 4 pi over 2. Now I can go ahead and add pi over 2 to both sides. Okay, so this is x equals 5 pi over 2. And let's check that graph out. So again, we see the highest this will get is 0.3 repeating, 1/3. The lowest this will get is negative 0.3 repeating, negative 1/3. And my end point here, where pi over 2, and then it's going to go up, come back down to the bottom, 5 pi over 2. So this is a 2 pi period, and those are the endpoints, one cycle. And it just repeats itself from there. All right, hopefully this helps you out with your graphs of your sine and cosine functions. Of course, there are other trigonometric functions to think about, and we'll learn about those graphs and how those interact with each other later on.